Yeah, okay, good morning. In previous class, we derived the formula for condition for maximum torque and the value for maximum torque value. So the general formula for torque tau equal to A S e to square R2 by R2 square plus Sx2. This is the expression for torque. So this torque completely depends on slip value S. So if you differentiate with respect to ds and equal to 0, then we get the condition for maximum torque. Condition for maximum torque. So R2 equal to Sx2. So here S means slip corresponding to maximum torque R2 by X2. Slip corresponding to maximum torque. So if you want to find the maximum torque, just substitute this value Sm equal to R2 by X2 in this equation. K Sm, sorry, K Sm e to square R2 by this one is maximum torque R2 square plus Smx2 whole square. So K into Sm value R2 by X2 e to square R2 by R2 square plus R2 by X2 whole square into X2. So K R2 square e to square by this one is X2. So this one is to take LCM X2 square. Cancel this X2 and this X2 square, then we get only X2. So R2 square X2 plus R2 square. Here I did some mistake. So K Sm e to square R2 by R2 square Sm X2 whole square. So this one is also square. So X2 square. X2 square, this X2 square cancel. So K R2, this R2, R2, K R2 square e to square by this X2. So the remaining value 1 by 2 R2 square. So this R2 square cancel. So K e to square by 2x2. This is maximum torque. And this will occur at Sm equal to R2 by x2. And the maximum torque is independent of rotor resistance, but the slip at which maximum torque depends on rotor resistance R2. Now torque slip characteristics. So the expression for torque will be equal to Ks into square R2 by R2 square plus Sx whole square. Here torque depends on slip. So the range of slip is slip is varied from 0 to 1. So this entire region is divided into two parts: low slip region and high slip region. Low slip region is generally from 0 to slip corresponding to maximum torque. This is low slip region, and high slip region is from slip corresponding to maximum slip to 1. So this entire slip is divided into two regions: low slip region and high slip region. Now at lower values of slip, so if you observe this equation, this torque equation, so denominator value is R2 square by Sx whole square. If S is very low, if S is low, S square is also very less. Suppose if you take slip S equal to some more 2%, 2% means 0.02. If you square it, it becomes 0.004. Then this value reduces very high value. So this value into this extra becomes very less. So R2 square value is very much greater than comparing with this Sx2 whole square value. So at lower values of slip, R2 square is R2 square means Sx2 is very much less than Sx2 whole square is very much less than this R2 square. So this term is neglected at lower values of slip. So torque is proportional to Ks. Torque is proportional to, here K is constant, E2 square is also constant, and rotor resistance is also constant. K proportional to, otherwise equal to K SE2 square R2 by R2 square. This R2, this square cancel. So the remaining equation K SE2 square by R2. So in this equation, this term, this term, this term, these three terms are constant. So torque is directly proportional to slip at lower values of slip. So it means that if slip increases, torque increases. So what is the meaning of increasing torque with respect to slip? So slip increases means load increases. So slip S increases means, so the formula for S is Ns minus N by Ns. So this value slip is increases if this N value reduces. If this N value reduces, slip value increases, and this value decreases due to increase of load. When load increases, speed decreases. If speed decreases, slip increases. So in order to compensate the increasing load, we need to develop the more torque. So that's why torque increases, torque directly proportional to slip for lower values of slip in order to maintain overload. So to compensate overloading of the machine, we need to increase the torque, and the torque is directly proportional to slip. So this is at lower values of slip. It means from 0 to SM. So slip becomes 0. If rotor catches synchronous speed, then only slip will be equal to 0. As you know, the formula for slip S equal to ns minus n by ns. If this n becomes ns, then ns minus ns by ns equal to 0. So if the motor catches synchronous speed, if the rotor catches synchronous speed, then slip value equal to 0. If slip value is 0, what is the value of torque? As if at lower values of slip, torque is directly proportional to slip S. If S is 0, torque is also equal to 0. So this is slip. So this is 0 slip, and this one is slip S equal to 1, and this point is slip corresponding to maximum torque, Sm equal to R2 by X2. And this is maximum torque. This is Tmax. This is our torque. Variation of torque with respect to slip. Here slip is 0. So slip 0 means ns minus n by. So slip 0 means rotor rotates at synchronous speed, n equal to ns at slip s equal to 0. Next, at slip s equal to 1 means n equal to 0. So slip equal to 1 means rotor speed equal to 0. It means rotor is under stationary condition. So under stationary condition, the torque developed by the motor. So general expression for torque tau equal to Ks E2 square R2 by R2 square plus Sx2 whole square. Substitute S equal to 1 to find the torque at slip 1. So K E2 square R2 by R2 square plus X2. This is starting torque, TST, starting torque. This is our TST. So this line represents slip corresponding to maximum torque. This line represents slip corresponding to maximum torque. So for lower values of slip, this one is lower slip and this one is higher slip. Maximum slip is 1. So at S equal to 0, at slip S equal to 0, torque equal to 0. So torque is 0. So next, tau proportional to S. As slip increases, this torque increases linearly up to maximum value. This is our maximum torque. This is variation of the torque with respect to slip for lower values of slip. Now for higher values of slip, so same the expression for torque tau equal to Ks P2 square R2 by R2 square plus Sx2 whole square. Now suppose if the slip is very high, you take slip high, Sx2 whole square is very much high comparing with this rotor resistance R2. As rotor resistance is very small comparing with inductive reactance, this value is neglected. So tau equal to K SE2 square R2 by S square X2 square. So this S and this S square cancel and remaining all terms are constant values. So torque is inversely proportional to 1 by S. So with increasing slip, torque decreases. If slip increases, torque decreases. When slip increases, so the formula for slip is S equal to ns minus n by ns. This value increases, this value decreases. So speed of the rotor decreases, n decreases if load increases. So if load increases, slip increases. So if slip increases, torque decreases. So from this relations we conclude that up to maximum torque only the torque increases with respect to slip. Once the torque reaches, the motor reaches to maximum torque, and again if the load further increases, then torque developed by the motor decreases. So this is at S equal to 1. S equal to 1 means So the rotor speed becomes 0, n equal to 0 at slip s equal to 1. So the rotor stops rotating and the torque at the time. Once the motor stops rotating, the torque at the time is nothing but starting torque, because s equal to 1. S equal to 1 means n equal to 0. If the rotor becomes stationary, then slip equal to 1 and the torque by the induction motor is TST, this point. So these are the characteristics of torque slip characteristics for lower values of slip.
Hi.
మౌలి
272.
చెప్పరా
సార్ ఎర్రా
నాకేం తెలుసు సార్ అక్కడికి వెళ్ళిపోరు
భోజనం చేయడానికి వెళ్ళారా ఏడ్చే
మహేష్ సార్ వచ్చేసాడు
సమంతగాడి
క్లాస్ కట్ అయిపోయిందండి
నేను కూడా ఏటో క్లాస్ పక్కన పెట్టి వేరే సినిమా చూస్తున్నాను ఏంటి ఆగిపోయింది అనుకుంటే క్లాస్ సార్ వెళ్ళిపోయారు
నేను అది చూస్తున్నాను ఏంటో బొమ్మ కనపడలేదు అనుకున్నాను
చేయకరా అయిపోయిందా క్లాస్ వాళ్ళకి
అంతేనంటే ఎప్పుడో మూవీ సగంలో ఉండిపోయింది
మధ్యాహ్నం నుంచే ఉన్నారు క్లాసులు
పిఎస్ సిఎస్
ఓహో గొప్ప క్లాసులే.
పిఎస్ లేదురా, మిషన్స్ మెజర్మెంట్స్ అని సిఎస్.
మెజర్మెంట్స్ క్లాస్ ఉందేంటి?
అయ్యి గొప్ప క్లాసులేనే.
సాయంత్రం మెజర్మెంట్స్ అని సిఎస్.
Your mic.
క్లాస్ ఉందా అయిపోయిందా అనుకుంటా పోదాం.
హాయ్ ఫ్రెండ్స్, క్లాస్ స్టార్ట్ అవుతుందా?
హలో, సారీ అండి, మైక్ డిస్కనెక్ట్ అయిపోయింది. నెక్స్ట్ నెట్ కూడా ప్రాబ్లం మొత్తం అయిపోయింది. జస్ట్ ఇప్పుడే చూశాను. చరణ్ కాల్ చేసాడు, ఎందుకు కాల్ చేసాడు నీకు స్క్రీన్ చూస్తే మొత్తం నెట్ డిస్కనెక్ట్ అయిపోయింది. సో ఎక్కడి వరకు విన్నారు? సో టార్క్ స్లిప్ క్యారెక్టరిస్టిక్స్ విన్నారు కదా అందరూ? టార్క్ స్లిప్ క్యారెక్టరిస్టిక్స్. హలో.
ఎస్ సార్, ఎస్
సార్
సార్.
ఓకే ఓకే. నెక్స్ట్ టార్క్ రేషియోస్ విన్నారా లేదండి?
నో సార్.
టార్క్ రేషియో
నిన్న చెప్పారు సార్ ఇది.
ఈ టాపిక్ చెప్పాం కదా. నెక్స్ట్ ఇది ఫుల్ లోడ్ టార్క్ అండ్ మ్యాక్సిమం టార్క్ రేషియో. నెట్ డిస్కనెక్ట్ అయిపోయిందండి, నేను చూడలేదు. ఏటీఎం కనెక్ట్ అయిందో నాకు ఐడియా లేదు. హలో.
సార్ ఫుల్ లోడ్ ఇది చెప్పండి సార్, ఫుల్ లోడ్ నుంచి.
ఓకే ఓకే. So this is expression for our torque tau equal to k SE2 square R2 by R2 square plus SX2 whole square. Suppose if you want to find starting torque, just substitute S equal to 1. So then k E2 square R2 by R2 square plus X2 square. Suppose if you want to find the maximum torque, substitute S equal to Sm, and the value of Sm is R2 by X2. So just replace S by Sm. K Sm E2 square R2 by R2 square plus Sm X2 whole square. Next, suppose if you want to calculate torque at full load. So to calculate torque at full load, we need to know slip at full load. This SF is slip at full load. So substitute KSF E2 square by R2 square plus SFX2 whole square. Now we are going to derive the ratio or relation between full load torque and maximum torque. So relation between full load and maximum torque. So to find the relation with the full load and maximum torque, just divide 2 by equation 1. Equation 2 by equation 1. So TF by T max equal to ASF E2 square R2 by R2 square plus SFX2 whole square by TM value. This is our T max. KSM E2 square R2 by R2 square plus SMX2 whole square. Now this k value cancel. E2 square R2, E2 square R2 cancel. So TF by T max equal to, here we have SF and here SM. SF by SM into, this will become numerator, this comes to a numerator. So R2 square plus SMX2 whole square, and again in denominator we have R2 square plus sfx2 whole square. Now divide numerator and denominator by x2 square. So Tf by Tm equal to Sf Sm into, so just divide by x2 square. So this become R2 by x2 whole square plus just Sm square. If you divide by x2 square, then it goes to then Sm x2 square by x2 square. X2 square cancel, then the remaining term is Sm square. Next, R2 by x2 whole square plus Sf square. But we know the formula for R2 by x2. We know R2 by x2 equal to Sm. So just replace R2 by x2 by Sm. Sf by Sm into Sm square plus Sm square by, this term becomes R2 by x2 means Sm square plus this one is Sf square. So Tf by Tm equal to Sm square 2 Sm square Sf 2 Sm square by Sm into Sm square plus Sf square. This Sm, the square cancel. So finally we have 2 Sm Sf by Sm square plus Sf square. So Tf by full load torque by maximum torque equal to 2 Sm Sf by Sm square plus Sf square. So this is the expression for full load to maximum torque. So here Sm means slip corresponding to maximum torque, and Sf means full load torque. Sorry, full load slip. This one is slip corresponding to maximum torque. So if you know the values of slip corresponding to maximum torque and full load slip, we can find the full load torque. So this is the relation. So next relation. Relation between starting torque and maximum torque. So same starting torque. TST equal to A SE2 square R2 by R2 square plus SX2 whole square equal to, here at starting condition slip equal to 1. So K E2 square R2 by R2 square plus X2 square, and maximum torque T max equal to KSM E2 square R2 by R2 square plus SMX2 whole square. This is equation 1 and this one is equation 2. Now divide equation 1 by 2. Starting torque TST by maximum torque Tm equal to Ke2 square R2 by R2 square plus X2 square. So this is TST by Tm value. Tm value is ASM E2 square R2 by R2 square plus SM X2 square. Now this K E2 square R2, K E2 square R2 cancel. So we have only 1 by SM into R2 square plus SM X2 whole square by R2 square plus X2 square. One by SM into, now divide numerator and denominator by X2 square. R2 by X2 whole square plus this one is SM square by R2 by X2 whole square plus X2 square. Sorry, this one is just 1, because if you divide with X2, this X2 square cancel, and this term is R2 by X2 square. R2 by X2 and this one is 1. Now R2 by X2 value same SM. So SM square plus SM square by SM into, this one is R2 by X2 is SM square plus 1. So 2 SM square by SM into SM square plus 1. SM the square cancel. So finally we have TST by T max equal to 2 SM by SM square plus 1. So this is the expression for starting torque to maximum torque. So this relation is also derived by using our previous relation. So we know full load torque by maximum torque equal to 2 SF SM by SF square plus SM square. So here slip corresponding to full load. So at the starting condition, the value of SF equal to just 1. This is starting condition slip. So just substitute SF equal to 1, then we get 2 SM by 1 plus SM square. So both are same. So try to remember these two relations. Just remember one relation. If you remember this relation, by substituting SF equal to 1, we can get this relation. Just remember this one. So 2 SF SM by just SF square Sm square. This is like a plus b whole square. A square plus b square and 2ab. In your numerator we have 2ab and denominator we have just a square plus b square. Just this is to remember this formula. Full load torque to maximum torque. So I hope it is clear to everyone. If you have any doubts, ask me. Otherwise, you can leave. Hello.
సార్
Yes, sir. Thank you.
Okay, and bye.
Thank you, sir.
Sir,